So in question 1, we're given two particles, one of mass 1.8 kilograms, the other one 1.2 kilograms. We're told that they're connected by a light string, which passes over a pulley. So if we would imagine what we have over here, we kind of have a pulley here. It's connected to some wall. And then we have a rope coming like this, going across it and coming down like this. And then we have the two masses here. We're told one of them is 1.8 kilograms, this one is 1.2. We're told they accelerate once they release from rest, and we need to find the acceleration and the tension. So to do this, what we need to do is write up Newton's second law equations. So firstly, we can know that there's going to be a tension here, and the tension will be the same over here, right? That's why we're told that we have a smooth pulley. So that just means that we have no frictional losses or anything. We kind of have the same tension on both sides. And then we will have the weight of both of these blocks pulling down. And we can write up the net force on both of these masses. So the net force on, for example, the left pulley is going to be 1.8 times the acceleration, right? So F net is equal to ma. And the net force will just be its weight, 1.8 g's, minus the tension. And the reason I can already write this down because I know that this will be positive, because the heavier block will obviously be accelerating downwards, so this weight force will be larger than the tension force. And then we can do the same thing for the second block, so we can just say 1.2a is equal to tension minus 1.2 grams. Here I do tension minus because again I want a positive number, and I know that the tension here will be larger than the weight. So now we are essentially ready to solve this problem. We just have two equations, two unknowns. So I just need to find a way to solve it. So for example, we can add both of these equations. In that way, the tensions will cancel out. And then I will just have 3a is equal to 1.8 minus 1.2, so 0.6 g. And then we can take g to be 10, so this is 6. And therefore, a is going to be equal to 2 meters per second squared. And then we're also asked to find the tension in the string. So we can just use any of the two equations. For example, we can say that tension is just 1.2 times the acceleration times plus 1.2 times g. So 1.2 times the acceleration is 2.4, and then plus 12, and this will give us 14.4 newtons